Morning, Year 6. I hope you're all safe and well. Today we're going to be continuing our learning on algebra. So if you can write down the date and learning intention, and we will begin. Super. Our learning intention today is to recognize how the sequence of calculations impacts the output. For today's lesson, you will need a pencil, paper, and your 5-minute timer. You'll also need some worksheets, which I'll show you at the end of this video. Onto our starter. So just as we usually do, I'd like you to get your 5-minute timer and pause the video whilst you write down your answers. Super. Now let's go through our answers. The first question is find the difference between 13 and minus 5. Now we know from 13 to 0, there's a difference of 13. The word difference means how much from one number to another. Between 0 and minus 5, there is a difference of 5. So we can add those two numbers together, 13 and 5, and we get 18. You may have done that mentally, or you may have chosen to draw a number line, like the one shown on screen, with positive numbers going all the way down to negative numbers. Whichever you have done, that is okay, as long as you got the answer. I managed to help you get the answer. Number 2, calculation and algebra. So I'm going to try my best to explain this without drawing lots of things, because I'm not that tech savvy yet, so I can't yet draw and show you exactly how to work this out. So I'm going to try my best by explaining it. The way to solve this, we know that 3m minus 5 is equal to 4n, and I've color coded each section to show us which part we're working on. So let's start with the first part colored in red. 3m minus 5. m must be less than 4, and n is a positive whole number. Now, we're not going to focus on n just yet. m has to be less than 4. So numbers less than 4, whole numbers less than 4, are 1, 2, and 3. Okay, those are our positive numbers that are less than 4. So let's try those. If we were to start with 3 and if we were to start with m having a value of 1, 3 times 1 gives us 3. And then 3 minus 5 gives us minus 2. That would mean that the red side there would all total minus 2. And then that would mean on the opposite side, we'd have to be trying to find a number that also equals minus 2. But we know that n is a positive number. So let's start, instead of starting with 1, let's start with a highest number less than 4. Let's start with the number 3. So 3 times 3 gives us 9. And then 9 minus 5 gives us 4. So now we know that the red side has a total value of 4. Now, if we use that, we know that the purple side then must equal 4, because the equal sign means both have to have the same value. 4 times what equals 4? Excellent. 4 times 1 equals 4. So that means our n is a 1. Excellent. So I hope that makes sense. N would have had to have been a negative number in order for us to have got the same number if we'd have multiplied it by 1. Okay, so for n to be positive, we had to do 3. So just to clarify our answers there, n is 1 and m is 3. Divide, don't worry if you don't get that one too much just yet, because obviously our topic at the moment is algebra. Hopefully that will make more sense over time. Now the next one we should know. So it says divide the fraction by the whole number, and we have 4/9 divided by 2. So to solve this, we need to use the inverse to help us. So we know that 4/9 divided by 2 is the same as 4/9 divided by 2 over 1. All whole numbers have a denominator of 1 if we change them into a fraction. So 4/9 divided by 2 over 1, well, that's still not going to help us very much. We're going to do the inverse to help us. We're going to change that 2 over 1 to 1 over 2. We're not going to change both our fractions, because then that would be pointless. we're going to change both. We're going to change one of the fractions, swap the numerator and denominator, and then we change our division into a multiplication symbol when we're doing the inverse, because we know that division and multiplication are inverse operations, just like addition and subtraction are inverse operations. Now we've got 4/9 times 1/2, and that is easy peasy. We just do 4 times 1 and 9 times 2, and we get 4/18. Then we can simplify that to 2/9, 2/9. So 4/18 can be simplified to 2/9 because the highest common factor that they both have is 2. So 4 divided by 2 is 2, and 18 divided by 2 is 9. Next question. What was the time 90 minutes earlier? So the time on the clock shows 15:28. What time was it 90 minutes earlier? So we know 90 minutes is the same as an hour and a half. So an hour earlier would have been 14:28, sorry. And then half an hour earlier than that, you'd need to take that away, and you would get the answer 13:58. You might also have written that as 1:58 p.m. or 2 minutes to 2 in the afternoon. Now lastly, Jamil says 3/4 multiplied by 1/3 equals 1/4. Is he correct? Yes, because 3 times 1 equals 3, and 4 times 3 equals 12. So he gets 3/12. And then Jamal has remembered that he needs to simplify that fraction. So he simplified it using the highest common factor that both 3 and 12 share. The highest common factor is 3. 3 divided by 3 is 3, and 12 divided by 3 is 4. So the number that he simplified 3/12 to, the fraction he simplified it to, is 1/4. So you'll remember yesterday we looked at function machines, and we talked about the purpose of a function machine. And I think I'm quite right in saying that most of you found that quite easy, which is great. That means you're on the right step for our lesson today. If you haven't done that lesson, I suggest that you do have a look at it and do go through it, because everything will be done in steps and stages. Okay, and we don't want to miss a step, because we all know what happens sometimes. If we miss a step when we're walking up the stairs, we can fall down. Okay, so we have to take the steps that are there for a reason. So yesterday we looked at one-step function machines. But what if our function machines contained 2 steps? That is our focus today. We will be looking at multi-step function machines. So, using the same process that we used yesterday, if I put 5 into our function machine and I times it by 4 and then subtract 6, what will my output be? So if my input is 5, times it by 4, subtract 6, what will my output be? Super. It will be 14, because 5 times 4 is 20, and 20 minus 6 is 14. Here is another function machine, albeit not as fancy. In this function machine, we have multiply by 2 and add 5. So if the input is 5, what will the output be? If the output is 19, what will the input have been? And if the input is 3.5, what will the output be? I'd like you to pause the video here whilst you answer the questions shown on screen. Fantastic. We'll go through the answers. So, if we put 5 into this function machine, 5 times 2 is 10. 10 plus 5 is 15. So our output is 15. But what is the input if the output is 19? Well, we need to use the inverse to help us here. We know that the inverse of multiplication is division. And we know that the inverse of addition is subtraction. And we have to remember that, okay? Because that will help us a lot when we're working backwards from the output to the input. So, because we're starting from the output, instead of adding 5, we're going to do the inverse and we're going to subtract 5. So, 19 minus 5 equals 14. And then 14 divided by 2 is 7. So our input is 7. And we can test it by going back in the opposite direction and seeing if our output is still 19. What is the output if the input is 3.5? Well, 3.5 times 2 is 7. 3 times 2 is 6, and then 0.5 times 2 is 1, so 6 plus 1 is 7. 7 plus 5 is 12, and so our output is 12. So here is a two-step function machine, and I would like you to have a go at working out the input and the output. So the first one we did together, we did 5 times 4 minus 6, and we worked out that it was 14. So now I'd like you to have a go at going through each of these and trying to find out either the input or the output. So if the input is 9, we times it by 4 and subtract 6, what will the output be? If the input is 80, what is the output? 700. And then what if the output is 42? Remember, we're going to use the inverse to help us today. The output is 194, and if the input is 2 1/4. Pause the video here whilst you write that down. Fantastic. Now let's go through the answers. If the input is 9, then the output is 30. 9 times 4 equals 36, and 36 minus 6 equals 30. If the input is 80, the output is 314. And remember, for that one, you could also, instead of for 80 times 4, you could just do 8 times 4 and use that to help you work out 80 times 4 as well. So always try and think, what are the shortcuts that I can use? Remember to use your logic hat and your method hat, always. If 700 is our input, our output is 2,794. And if 42 is our output, we need to do the inverse to work out the input. So 42, instead of subtracting 6, we're going to add 6. So 42 add 6 gives us 48, and 48 divided by 4 gives us 12. 194 is our output, 50 is our input, and if 2/4 is our input, then 3 is our output, because for 2/4 we could do 2 times 4, which is 8, and then 1/4 times 4, well, we know it's 4 quarters that make a whole, so a quarter, if we have 4 quarters, we just have a whole. So if we put our 8 and our 1 together, we have 9, and then 9 minus 6 gives us 3. Well done if you managed to get those. Now I'd like you to have a go at completing the table for the given function machine. So you'll see the row on top where it says input, that tells us the number that we're putting into our function machine. This function machine multiplies by 3 and then subtracts 4. What will the output be? I'd like you to write down the function machine and the table onto your paper and then complete the table. Once you've done that, answer the following questions. What patterns do you notice in the outputs? What is the input if 20 is the output, and how did you work that out? Excellent. So these are the numbers that you should have in your grid. Well done if you got those. If you didn't, well done for trying your best. See if you can maybe see how we managed to get those answers. So 1 times 3 is 3, and then 3 minus 4, well, we know we're going to go down to minus 1. What patterns do you notice in the outputs? Are they increasing or are they decreasing, and by how much? That's right, they increase by 3 each time. So that means they're adding 3 each time. So minus 1 and 3 is 2, 2 add 3 is 5. There is a pattern there. Whenever you're doing any type of maths work, it's always key to try and look for a pattern, because the pattern will make it easier for you to solve any of the problems that you're going to come across. There's always a pattern to see if you can find it. What is the input if 20 is the output? And how did you work it out? So you might have worked it out in a number of ways, but the two ways that I'm assuming most of you would have worked it out are like this. You may have continued the sequence in the output. So you might have realized, if we're adding 3 each time, then I'm going to keep adding 3 until I get to 20. So then you would have carried on 14, 17, 20. And then you might have then continued the sequence in the input numbers until you also add another 3 numbers, so 6, 7, 8, and realized that if the output is 20, then the input must have been 8. However, some of you might have worked it out like this. You may have remembered our function machine and done the inverse. So 20, add 4, then divided by 3. So 20 add 4, divide by 3, and that gives you 8. Because 20 add 4 is 24, divide that by 3 is 8. Now you'll notice when I've written that out, I've had to put brackets around 20 plus 4. Just stop for a moment and think about maybe why I have done that. Super. I've put 20 plus 4 in brackets to show that you need to do that first. Because we know the law, the rules, the order of operation tells us that the division should be done before addition. But if I put the brackets around it, then it tells us that we need to do that operation first. And that's why we use brackets. Because sometimes if we're breaking the traditional rules, the bracket tells a person that actually this is what you need to do first. Now I'd like you to have a go at completing the table for the given function machine. Just as we did, to complete the table and then answer the questions again. But for this one, whether you use the first method or the second method, shown on the last screen, I'd like you to use the second method this time. So using the inverse to help you work out what the input will be if the output is 48. And let's go through the answers. So this function machine multiplies by 5 and subtracts 2. If our input is 1, our output is 3. And there's all our outputs on screen. What patterns do you notice? Are they increasing or decreasing? Excellent. They are increasing by 5 each time. And it's important that you try and use some of the vocabulary that I'm using with you today. So instead of just saying they go up by 5 each time, try and use that mathematical vocabulary. They increase by 5 each time. So if the output is 48, then the input is 10. And we can do that by doing 48 and going back doing the inverse. 48 plus 2, which gives us 50, and then 50 divided by 5, which equals 10. Well done. So Amir puts M into these function machines. He's got 2 function machines. The first one, we can see multiply by 2 and add 1, and then you get your output. Whereas the second function machine, add 1, then times by 2, and you'll get your output. M, in this question, represents an unknown number. Okay? So it means it might represent 1, it might represent 3, it might represent 10. It will represent an unknown number. So, before we begin, I want you to think of a number between 3 and 8. Any number. All your numbers will be different. Keep that number in your head. That number that you've chosen is our M. And that's the same number you're going to put into both of Amir's function machines. Amir says the outputs of the machines will be the same. Do you agree or disagree? Now the best way to show whether you agree or disagree is to prove your answer. So if you say you agree, how do you know? What evidence do you have to prove that Amir is correct? If you disagree, what evidence do you have to prove that he is incorrect? So you'll need to have looked at some examples that you can provide in your explanation. Say you've all chosen different numbers, but I'm going to share with you in just a moment the number that I've chosen. But for now, I just want you to write down your answer. Super. For this, you may choose to use some different resources to help you. So you might want to have a go at creating maybe your own function machine and then putting things in, creating your input and your output and changing it, put a post-it on the top, 1 multiplied by 2, add 1, and the other one, add 1 times 2. It's up to you. So for some of you, you might prefer to see things and actually touch things as you're learning, and that's okay. Whereas for others, you might prefer not to, and just to write down the process. So, whatever your answer was, whatever answer you've written, I'm going to give you an example of an answer that I would have used, but using a number that's probably different from the number that you've chosen, but that's okay. So, if m represents 5, then let's test and see whether the output will be the same. 5 in the first machine. 5 times 2 equals 10. 10 plus 1 equals 11. So our output was 11. Input was 5, output was 11. Now, let's see if I get 11 on the second machine. 5 plus 1 gives me 6. 6 times 2 is 12. Did I get the same output? No, I didn't. I got 11 on the first and 12 on the second. So, is Amir right? No, he's not. Why do you think that Amir is not correct? Well, we could say Amir is not correct because we cannot just swap the order of the numbers and the operations. We can't just swap them around. These operations, they're not the inverse of each other. They're completely different. So we can't just swap them around. Where they are in the sequence is important. So as I said earlier, you may wish to make your own function machine, and you may wish to just play about with a two-step function machine before you go on to a lot of our written work. And if you need to do that, that's okay as well. Okay, so you might want to use some coins, maybe have some copper coins and silver coins, and put those into your function machine as you get used to them. So Teddy has 2 function machines. The first one has plus 5 multiplied by 2 and then the output. The second has multiplied by 2 and add 5 and we get our output. Teddy says the function machines will give the same answer. Is Teddy correct? Now, thinking back to the question that we've just done, is Teddy correct? I'd like you to write down your answer on your paper. Super. And is there an input that will give the same output for both machines? So this one's a little bit trickier, but we just needed to think about what we talked about on the last one. Will both of the machines give the same output? Well, we need to test our theory, don't we? So we need to test it, choose a number and see. So say I had 10 in the first machine. 10 plus 5 is 15. 15 times 2, 30. So the first machine, I put in 10 and I got out 30. Now the second machine, I'm going to put in 10 as well. 10 times 2 is 20. 20 plus 5 is 25. So I put in 10, but I got 25. So we didn't get the same output. So no, Teddy is not correct. But I want you to play about with some different numbers and see, is it possible that you can get the same, that you can get both machines to have the same output, depending on the number that you choose for your input? So, answer shown on screen, just an example of how you might have written it. No, Teddy is not correct. If the input is 3, then in the first example, the output would be 16. So again, just using an example to support whatever answer you have given. This function machine gives the same output for every input. For example, if the input is 5, then the output is 5, and so on. What is the missing part of this function? So we know in this question it tells us that the input and the output is the same. So if I put in 5, I'm going to get 5. If I put in 10, then I'm going to get 10 at the end. What is the missing part of this function? What other pairs of functions can you think of that will do the same? So what's the missing part? If I put in 5 and I multiply it by 2, I've now got 10. What do I need to do with that 10 to change it back to a 5? Excellent. I need to divide it by 2. So whatever I put in, whatever I do to it, whatever I do to that number, if I do the inverse, the same amount, I get the same number out again. What other pairs of functions can you think of that will do the same? That's right, you guessed it, addition and subtraction. So if I put in 5 and I add 2 and then take away 2, I'm going to still have 5. If I put in 5 and I add 100 and take away 100, I'm still going to have 100. So because addition and subtraction are the inverse, they help me to get the same answer. And it's the same with multiplication and division. How can you write this two-step machine as a one-step machine? So if we've got our input and then add 3, add 5, and we get our output, then check your answer by inputting the values. Now, I want you to pause the video whilst you have a think about how you can change this two-step machine into a one-step machine. Remember, check your answer by inputting values. So choosing numbers as your input to see if it works. Super. So we'll go through the answer. So say we put 3 into this machine. 3 plus 3 gives us 6. And then 6 plus 5 gives us 11. So our output would be 11. Now let's try it with a different number. Say we had 40 and we put that into the machine and added 3 and then added 5. Our output would be 48. How can I, instead of making it a two-step machine, instead of adding 3, then adding 5, what could I do so I just have one step? That's right. We could just add 8 because 3 plus 5 makes 8 anyway. That's all we did. We added 3, then added 5. It's the same as adding 8. So we could just change this into a one-step machine by just adding 8. 3 plus 8 equals 11 and 40 plus 8 equals 48. Exactly the same as the one above. So Mo has the following function machines. Which of these function machines can be written as single function machines? So I want you to pause the video here and just think about which of these could be changed into a single function machine. Super. Thinking about all that we've been talking about throughout this lesson today. So the first one could be changed into a single function machine because the numbers, the two operations shown, are the inverse of one another. The second could also be changed into a single function machine. So let's say, for an example, if I put 4 into the second one, 4 times 8, what would I get? Excellent. 4 times 8 would give me 32. Now, if I did 32 and I divided that by 2, I would get 16. So my output would be 16. So instead of me timesing by 8 and then dividing by 2, what if, instead of going up high to then have to halve that number, what if instead I just halve that number in the first place? And I just times by 4. So instead of timesing by 8, I just times by 4. Because when we go up to 8 and then halve it, that's all we're doing anyway. And the last one, can that be written as a single function machine? No. And we know that just by looking at the operations. We've got multiplication and subtraction, and they are not the inverse. So no, we cannot. And we can test that because if we have 5 times 2, that would give us 10, minus 8 would give us 2. How can we get from 5 to 2 using just a single function machine? Well, we wouldn't be able to change what we have there. Instead, we'd have to change that completely into just subtraction. So it'd be completely different. So we wouldn't be able to do that there. So that marks the end of our lesson. What next? So for some of you, you may wish to go on and make your own function machine. You might want to just grab a box and just play about with that practically. So you're getting used to having your input, working out what you need to do with those numbers. Choose maybe some tricky numbers, not 1 and 2 like I've shown in the example. Choose some trickier numbers, making sure that you're really good with your calculations and then working out the output. But then once you've done that, seeing if you can spot maybe what the pattern will be. Okay, so then if the function machine stays the same, you put 1 in and you get this answer. So if 1 is your input and then you find your output, 2 is your input, you find your output. See if you can predict what would if you put 20 in, what would the output be? For some of you, you may wish to just go straight on to the writing. And the first worksheet shown, the 2-step function machine, again, that's quite simple. So that's just really reinforcing the practical task that I just explained. But for most of you, you'll probably be going on to the reasoning and problem solving, which is the one shown in the bottom right-hand corner. So looking at the problems and thinking about how you would solve them. Okay. If you want to continue, you could go on to top marks, where you'll find some more work on function machines. Or you could log into your Mathletics account, where we have assigned work for you. Okay, for this unit. Either way, please make sure that you send us any of your work that you do at home. Before you go, just a quick reminder that everyone learns at a different pace, and that is perfectly fine. So the work that I'm giving you will vary from day to day, and you will need to choose your starting point. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. But by all means, keep moving. So even if you find something difficult, don't give up. Keep trying and trying. Slow it down. Take it at your own pace. Do whatever you need to do to achieve your goal, to be able to understand it. Okay, but whatever you do, do not give up, but keep trying and trying and trying, because you will get there. As long as you're trying, you're moving that much closer to your goal. So on that note, here is our success criteria. You can pause the video here, read through each of the statements, and then look at the pictures beside them, and that will tell you if you can't answer yes, I can do that, then you need to go back to that point in the video and watch that part again. So we'll go through the first one with you. I can use a model function machine to recognize the relationship between the input and the output. So if you think, actually, I could use a model, I could use a box in front of me and say, yep, this is what's going to happen with the input, this is the relationship, that will come out. If you can do that, perfect. You can move on to the next. But if not, then you need to go back to this point in the video where I talked about making a function machine. Have a look through each of our success criteria, see whether or not you can do it, and if not, go back to that point in the video and watch it again. As I said, remember to email us your work at yr6@grange.harrow.sch.uk. Have a great day, Year 6.